Hello students. So welcome to the class of Programming and Data Structure at the Indian Institute of Technology Kharagpur in this autumn 2020. So today we are going to discuss on iterations and loops. So there will be 3 lectures, each containing about 1 hour. So this is the part 1. Okay. So before we go into the detailed discussion of these iterations and loop in C programming language, so let me give you some motivation for this. As of now, the programming language what you have used, you have seen that okay, there are simple statements, and those simple statements when are packed inside a closing and opening braces, then it will constitute one block, and that block of statements are being executed. Now there may be some situation where there is a need of executing a block of statements a number of times. Okay, so one example can be that if I ask you to add n natural numbers without using any equation. Okay, so basically 1 plus 2 plus 3 plus 4 plus 5, that way if I ask you to add, instead of say n, 100 numbers, then what you will do, that every time you have to write one addition statement, and that way your source code will be very long. Okay, so that is one situation. Another situation is that if instead of say 1 plus 2 plus 3, for this example you can think okay, there is a very simple equation, and using that particular equation I can easily compute the sum. Then I can give you another situation where say it is not adding the n natural numbers, but user will give you input, and based upon that input you have to keep on adding 100 numbers. If I assume that user will supply you 100 numbers, and since user will supply you 100 numbers, so there is no guarantee that what will be the number, so you have to add them, and say based upon the data you have to output the sum as well as the average of that one. Now if that is the situation, as of now what you have studied, based upon that you can think of declaring one say variable, say integer sum. If I assume that user is going to give you one integer numbers, and you need to add them, and then you have to compute the average, so you will actually declare one integer variable say sum. You will initialize that one with 0, and you will keep on adding sum with the user input, and when you will take the input, then you will take one variable for one data, second variable for another data, that way you will keep on doing, and if you reuse that variable also, then so you have to write several statements. What we are planning to do is that instead of that, if it is possible, that I will have some construct through which if there are similar set of statements or a block of statements which will iterate or which will occur more than once, we can have some construct through which we can minimize the source code of that one. So based upon that one, loops are defined. It is said that group of statements that are executed repeatedly while some condition remains true. So that is important, some condition remains true. So what is the condition? I will discuss in the next slide. Okay. Now if that condition remains true, then it will keep on iterating, and each execution of the group of statements is called an iteration of the loop. So one execution of one group of statements or a block, you can consider that one iteration. Another execution of group of statements, another iteration. That way it will keep on iterating until a condition remains true. Okay, so the essentials of repetition in loop, as I mentioned, it is a group of instructions computer executes repeatedly while some condition remains true. Now this condition can be of two types. Based upon that one, I can broadly classify into two groups. One is counter control repetition, another is sentinel control repetition. In case of counter control repetition, I know beforehand that how many number of times the loop will iterate, or definite repetition, and I know how many times loop will execute control variable used to count repetition. So that is one situation. Say for example, as I mentioned, I know that user is going to give you 100 numbers as an input, and I have to compute the sum and average of those 100 numbers. So I know a priori that 100 numbers are going to be supplied. So I know that 100 numbers. Not the content of the 100 numbers, but I know that 100 numbers will be given to me. For sentinel control repetition, it is indefinite repetition in sense that it will keep on iterating until a particular control input is provided. So it is indefinite, but it is not infinite. Infinite is a separate thing, we will discuss separately, but this is indefinite. So unlike to counter control, when I know that how many number of times the loop will iterate, in case of sentinel control repetition, when the program executes, it may not know how many times it will iterate. It is used when number of repetitions not known. Sentinel value indicates end of data. Okay. So if I modify little bit my previous example, where I assume that say 100 numbers, 100 different numbers are given as an input, then I mention that is counter control repetition, because I know for definite or for surety that 100 numbers are there. In case of sentinel control repetition, it can be that okay, so user will give you input and you have to read, you have to add, and you have to compute the average of those numbers until you reach to one number where the number is say -9. And if it is the case that until you reach to -9, then you know that you do not know that when it will reach to the -9. It can be the first character, first input, it can be second, it can be third, or it can be any input. So when the execution starts, I do not know. That's why it is called as the indefinite repetition. But there is a termination, and that's why it is sentinel control repetition, that when I will reach or I will encounter to that particular input, then I will stop. In this case, the end of data I am assuming is -9, but definitely it will vary, and it will vary from case to case. Here is the first example of one iterative situation. The input is 5 integers and display their sum. Very simple thing, and you see that it is a flowchart. Initially we will demonstrate using the flowchart, then we will map to some programming construct. So first, this is your start node. From here, then what I am doing, that first I am initializing two variables. Now you know that since it's a flowchart, so exact syntax of C is not required, only an indicative or pseudocode is enough. That's why instead of equals to, I am giving an arrow. So initially I am assigning 1 to counter, or counter is initialized with 1 and sum is initialized with 0. This counter variable will actually keep track of how many numbers has already read, and that way it will control that how many is remaining. And definitely I know that since 5 integers are to be read, so it is a counter control iteration. On the other hand, sum is a variable where the sum of 5 integer values will be stored. Since it is an integer addition, and it is an addition, so sum is initialized with 0. Next, I am going to checking the condition. So it will test the condition that whether the counter variable is less than 6 or not. So first you may think that okay, just now I initialized counter with 1, then what is the need of checking that whether counter is less than 6 or not, because I know that it is going to be less than 6. But here there are two entry points for this particular node. One is coming directly from here, another from this left hand side. Why this left hand side? I will come to that, and then you will understand that indeed this testing is required at this position. Now you know as of now, based upon your conditional operator, that after this testing there are one of the two outcomes. Either it can be evaluated to true or it can be evaluated to false. Now if it will be evaluated to true, which means that counter is indeed 1, then definitely this will be evaluated as true, which means 1 less than 6. Then it will come down, then it will input one number from the user, and then it will add that particular number with the sum. I initialized sum with 0, so it will be added, and after that addition it will come down again, then it will increase the counter, or I can say that it will increment the counter by 1. By this I am also informing that one read operation and one addition operation is done. So in this case, the a group of statements which are being repeated, repeating and which will be inside the loop is this input and this addition operation. But to deal with this basically loop construct, I need to incorporate this counter variable, which will be tested here and it will be incremented here. Now after this increment, you see that next flow is not downward, rather it is left, and then it is going up, and kind of a jump statement, unconditional jump to this condition testing. Now you understand that this condition testing is indeed required, because after this increment it will come back here. For the first step it will be 2 less than 6, true, then it will come, it will execute, then 3, then 4, then 5, then 6, and after this 6 it will be tested as false, then it will come down from here directly here and it will output the sum. So that is all about the loop and the iteration. Now again to tell you that the statement or group of statements which are being repeating is input n, sum equals to sum plus n. Now from here you can see clearly that if this kind of loop construct is not there, then basically you have to write input n, sum equals to sum plus n for 5 number of times, since 5 integers are supplied by the user and you have to display their sum. Whereas by incorporating this loop construct and one extra variable and corresponding to that this condition testing and this increment of the loop, then only one read and sum is enough. And you see that using this construct it is not only 6 but any number of inputs can be added. For that you need to change only this 6. Okay. So here is another example which says that given an exam marks as input, display the appropriate message based on the rules below. What is the rule? If marks is greater than 49, display pass, otherwise display fail. Now if I stick up to this point, then you understand that only one if else condition will do the needful. But it may be possible that an user which is novice and do not know much about the exam system or about the marks may give some negative number or may give some number which is more than 100. But I know that exam marks can vary only between 0 and 100. That's why I am giving one restriction, that however for input 0.2, however for input outside the 0 to 100 range, display wrong input and prompt the user to input again until a valid input is entered. Okay. So here the situation demands that okay, you allow the user to keep on giving the marks as an input. so that I can comment whether that particular marks will evaluated as pass or fail based upon the threshold value 49. But if the number is not within 0 to 100, then I will keep on asking that give me number, it's a wrong input. So using that message I will keep on asking. Now you see that unlike to previous one, for this case if I go back, then in this case I know beforehand that 5 integers will be supplied. That's why my construct was that I know, and the condition was set as counter less than 6. In this case, in this marks, I do not know that how many times an user can make a mistake. It may be the first chance where he will give the correct marks and then it's bingo. But if it is not the correct marks, then he can give some negatives, more than 100, etc., etc. For those cases I will keep on looping, but how many times I do not know. So it is indefinite. And for that my loop construct look like this. So first at the top is my start symbol, then again in this flow chart, so this arrowhead actually is occluded by this shape. So input M, so M for marks, and then you check whether M less than 0 or M greater than 0. If it is true, then M less than 0 or M greater than 100, M less than 0 or M greater than 100. If it is true, then it is a wrong input. You output that message that it's a wrong input and you ask for another input, and then you go back here and keep on checking, and it will keep on looping here until you will get one value which is between 0 and 100. Once you will get, then the condition will be tested as false, then the flow will come from here to here. Now this condition testing is the thresholding to check whether the student has the pass mark or fail, and if it is true then it is pass, otherwise it is false, or if it is false then it is fail. Now the loop actually will occur in this input. Now you understand as of now what kind of programming you have done for practice or from the laboratory session. Then you can have a small piece of this particular code so that the input is within a particular region. Otherwise you may have a wrong input, and based upon that one some mistake may happen. So for example, that you are say wish to you are writing one program to compute the square root, okay, and the first number somebody has entered is a negative number. Definitely there will be a problem. So those kind of situations to deal with, so what you can do, this particular module you can give as during the input. So you take the input, accept the input when only it is allowed one. Otherwise you send a message to the user, say you are we are going to compute the square root, so you do not give me the negative number. So in this case you are sending the message, instead of say wrong input you can give a long message like you are supposed to give a mark which is within 0 and 100. Then you are basically guiding the user, and then user will give you the correct value. We hope so. Now here is the loop construct or the C syntax for this loop. So while is your basically the keyword and for the loop. So this while, within this parenthesis expression, this expression will be boolean in nature. So if it is true, then this particular statement will be executed. If it is false, then from here it will go out of this statement. So it will not be executing the statement. There are two different variations of this, you can see clearly. One is within braces, another is without braces. So the difference between these two is when you have only one single statement, then opening and closing brace is optional. But if you have block of statements, then these opening and closing braces are mandatory. Okay, but I will insist and I will also suggest that irrespective of whether it's a single statement or block of statement, it is always a good idea to make a habit of opening and closing braces while you are using this while loop. Okay. Now, as I mentioned, the condition to be tested is any expression enclosed in parentheses. The expression is evaluated, and if its value is non-zero, the statement is executed. Then the expression is evaluated again, and the same thing repeats. The loop terminates when the expression evaluates to 0. Okay. Now, if I draw one flow diagram, it will be looking like this. So, the initial flow is coming from the top, following this vertical line, this vertical arrow. Then expression will be tested. If you draw a mapping or correspondence from this expression and this while expression, then this expression will be tested. If it is true, then only statement or block of statements will be executed, otherwise it will not be executing. And after the execution is over, block of statement or statements, control will always go back to this expression. So after this one, the control will go back to this expression. The expression will be evaluated again, and then if it is false, then it will come out. If it is true, then it will go to executing the statements again. Okay. Now here is an example of this while loop. We are not, for this time being, we are not including that has include stdio.h, int, main, etc. I think that you are smart enough now that you can include that one. So we are just focusing on the while loop, and in order to do that one, we are declaring the required variables and reading the required input. Okay. So first declaration is int I equals to 1 comma n. So I is being declared as an integer variable and assigned with the value 1. Then I am declaring also a variable n. So n is being going to be the limit for me. Next, I am reading from the user that using this scanf that how many times I have to write that one. Then in the while loop, while I less than equals to n, printf line number colon %d/n I, and then I equals to I plus 1. So after printing one line, then I will be incremented. So from 1 to 2, then 3, 4, 5, 6, and based upon what is the input, it will be executed. Now I understand some of you may have a question that, okay, if somebody supplies initially some value less than 1, maybe 0 or maybe negative. If it is the case, then clearly you can see that this while loop at the very beginning will be tested as false. So nothing will be printed, even not a single printf statement will be executed if the initial input is n equals to 0 or less than 0 or some negative value. But if it is a non-zero positive number, then based upon what is the number, so many number of lines will be printed, and 1, 2, 3, 4, because you can see that it's I. So I was initialized with 1. So 1, then I will be incremented to 2, then I will be incremented to 3. That way it will keep on incrementing and it will be printing. Okay. Here is another interesting example. So it says that integer weight. Okay, I am assuming that weight is integer for the time being. For that we can take the float function, not the ceiling. Okay, so if say it is say 64.1, then we are taking 64. If it is 64.9, then also we are taking say 64. Okay, now if it is the case, then scanf %d ampersand weight. Okay, by the way, that taking 64.1 or 64.9 is my initial assumption, and as a user, assuming that one, I will give the input, because here the weight is declared as an integer variable. So if it is a floating point variable, then that kind of assumption I should not have. But since I am writing a program where weight is an integer and I am reading using scanf %d ampersand weight, then definitely I have to input some integer value. But as I understand, and you know that weight cannot be integer, it will be floating point. So either you have to take the ceiling or floor. So whatever you take, that particular integer number will be the input. Now after giving that as an input, my statement is while. So that is the loop construct, and if weight is greater than 65, then I am printing go exercise, then come back and enter your weight. After that one, here you see that unlike to previous examples, there is no counter variable, where the last statement, yes, the last statement, I am going back, this last statement in this loop is the increment operation on the I, which is basically controlling this loop. Okay, unlike to that one, here there is no increment, rather I am basically reading the weight. But the similarity between the previous and this example is that in both the cases, this particular variable is basically controlling the loop. So loop control variable I can call them. Okay, now this weight I will read and I will test, and it will keep on looping as long as my weight is greater than 65. Now in this particular case, if there is a wrong input like weight is negative or say 0, then it will not suggest for going for exercise. Or if say weight is even 64, then also it will not suggest to go for exercise. But as long as weight is more than 65, it will suggest for exercise. Now from that point of view, you understand that for this particular case or example, it is not required to basically give the checking on the weight. If somebody gives some less amount of weight, fine, I am not suggesting to go for exercise, so there is no harm. Okay, so irrespective of whether a negative weight or less than 65 weight, I am not suggesting anything, but only the weight is greater than 65, then only I am suggesting for the exercise. So from that point of view, you understand that checking on the input may not be required. You can give, but it is not that much required here. Now this is a complete example of sum of first n natural numbers. Again, I am explaining this one without using the equation. Now I know that there is equation through which you can easily compute the sum of first n natural numbers, but we are demonstrating because of its simplicity using this particular example, and then we will extend it to others, and I believe that then it will be easy for you also to understand. Okay, so int main, and there is no argument in main, then opening brace. Next variable I am declaring int capital N, count and sum, these three variables. So in is for controlling the loop, count is for controlling the loop, and n is the first n natural number, the limit on the natural number. Sum is the variable where the sum will be stored. Okay, next I am reading the limit, that is the n up to which the sum will take place. Then sum equals to 0, I am initializing with that one. If you remember our flow diagram, then so I was initializing sum with 0, then count was initialized with 1, and it is required. Next what I am doing, while count less than equals to n, sum equals to sum plus count, count equals to count plus 1. So count increment is for controlling the loop, but actual statement is this one, sum equals to sum plus count. This way it doesn't matter what is the size of n, it will keep on iterating and looping, and this much is your complete code. And from that point of view, it is advantageous. Now if instead of this loop, if you wish to write it in separate lines, then the lines of code may increase based upon that what is the input, and also in that way keeping it a variable will be very difficult, and sometimes you cannot able to do that one. However, from computation time point of view, so what will be the difference, you can think about that one. Okay, that if I use the loop, then whether it will be expensive, or if I do not use the loop, then it will be expensive. You can think of that one. Nevertheless, once this loop execution is over, then you come out of there and then you print sum equals to %d sum, and then you return 0. You know that since I am writing int main, that's why I have to put a return 0. statement here. Now here is another example of sum equals to 1 square plus 2 square plus 3 square plus dot dot up to n square. You can extend the previous example for this addition also. Only difference or only modification you have to do that in this line sum equals to sum plus count. This much was discussed previously, sum equals to sum plus count. Now because 1 square plus 2 square plus 3 square etc. So this count multiplied with count is added here. So that is the only difference. Now one more thing I wish to highlight here, that since I am doing 1 square plus 2 square plus 3 square etc. So the square will get the priority. That's why this count multiplied with count as per this equation may be put inside a parenthesis, but as you know, based upon the precedence of the operator, this multiplication will take place before this addition. That's why the parentheses are optional here, but if you feel you can put a parenthesis, and that is not a very bad thing, rather I will suggest that is a good practice, so that in future or say when you will do the documentation, or in future when you will come back and look at the program, then by looking at a glance you can quickly figure out that what is the equation or how can I infer that one. So that will be important here. Okay. Now another example is the computing the GCD of two numbers. So two numbers are given here, 12 and 45. So I believe that you remember how to compute the GCD from your school days. Okay. So first what I am doing, I am dividing. So first I am identifying that which one is the larger one between this 12 and 45. Clearly 45 is the larger one. So I am dividing 45 by 12. After the division, my remainder is 9, because 12 multiplied with 3, 36 here, and the remainder is 9 for me. And since my remainder is 9, so now I am dividing 12. 12 is coming from here to here, so I am dividing 12 by 9. After this division, I am getting 3 as a remainder. Now I am dividing 9 coming from here by 3, and after this division I am getting 0 as a remainder. And my stopping criteria is that for this GCD calculation, so this stopping criteria as per the definition of the GCD is when my remainder will be 0, then I will stop. Okay, so that is my stopping criteria, and that I need to code, or I need to write a program which will take two integer numbers, and then it will compute that what is the GCD of two numbers. In order to do that one, before I directly go to the program, few things I wish to tell. One thing is that when you are asking the user to give you two numbers, then it may possible that user can give you 12 and 45, or user can give you 45 and 12. So what I wish to mention, that the order may not be important to the user, but for you, in order to do the calculations, since the larger number will be divided, so you have to know which one is the larger and which one is not. Okay, so that is the first thing we have to decide. Next thing is that during this division, the important is not the division part, but important is the remainder. Now you know there is an operator in C, that is percentage. If you apply the percentage, then directly you will get this remainder. So I will not do slash division, rather I will do percentage division in this case in order to get the remainder. Second thing. Third thing is that when basically I am dividing this one, then you see what is happening. Initially I am deciding, and say I decided that okay, 12 is the smaller one and 45 is the larger one. So I will divide 45 by 12. After the division, I will get 9 as a remainder. After getting this 9 as a remainder, then I have to divide 12 by 9. So this is going here, and this remainder is my new number which I got using this division, and I have to divide this number by this 9. After this division, again I got a remainder. Now 9 is my new number, and I have to divide this this 3 is my new number, and I have to divide 9 using this 3, and this way it will keep on moving. So there is an exchange. Those three things will be incorporated in my program. So first int main, then I am declaring three variables a, b and temp. So a and b for taking two inputs, two variables, and temp will be used for exchanging. So what is the exchange? I will come to that one. So first I am writing scanf %d ampersand a and ampersand b. Then if a greater than b, then what I am doing, I am exchanging. So after this exchange, I ensure that b is always greater than a. So if two numbers are same, there is a separate treatment, I will come to that. But if a is strictly greater than b, then what I am doing, I am copying the content of a into temp, then I am copying the content of b into a, then I am transferring the content of temp to b, and that way you see that now after the execution of these three statements, so the content of b is transferred to a and the content of a is transferred to b. Okay. So first, excuse me for writing all these three statements in one line, so that I can keep all the whole program in this slide itself. Now regarding this exchange, you see that if I do not consider this temp variable, so this first statement and this third statement is not there, then this a equals to b will spoil the value of a, because the moment I will assign b to a, then the content of a will be lost. So what I need to do, that before I assign the content of b to a, I need to preserve or store the content of a in some other variable, and for that purpose I am using this temp variable where the content of a is being copied, and after copying the content of a into temp, then what I am doing, now I have no problem, I can destroy the content of a by overwriting the content of b, and that way the content of b is now transferred to a, and b and a are with the same content, whereas temp is with the content of a. So in the third statement, the content of temp, which is the content of a, is actually copied to b. Okay. So these three statements are very important statements. You may see this frequently in other examples also. We will use this kind of statements, three statements specifically, where we wish to exchange two numbers, the content of two numbers. If we wish to exchange, then by incorporating one more temporary variable, I can do that one. Okay. In this case, the whole purpose is to ensure that b is always greater than a. Okay. And if b is always greater in this case, if say for example in the input, if b is already greater than a, then this condition will not be evaluated and there is no need of executing this statement, but otherwise it will be executed. Next, while b modulus a, you know this modulus or percent operation will give you the remainder not equals to 0, then temp equals to b modulus a, b equals to a, and a equals to temp. In this case also you see some sort of exchange, but not between two variables, but some changes are there. So I will go to that one. But first let us assume that if the content of b and a both are same, then at the first occurrence of this statement or first execution, during the first execution of this statement, this will be evaluated as 0, so it will be false, so it will come out of the loop, nothing will be executed inside. But if it is not, and I ensure by this time when I am at this while loop, I ensure that either b equals to a, then it will be executed, but it will be evaluated as 0, so this while loop will not go further. I will come out of here, but if it is not, if a not equals to b, then I can divide b by a, because I ensured that the value of b is going to be the larger compared to the a. If not, then there was an exchange, and because of that exchange it has been ensured. Okay. Now after that one, after this division, so the remainder part will be stored in temp. So if I consider this example, so 45, it will be divided by 12. After the division I will get 9, that will be stored in temp. Okay. Now I have to divide 12. So this 12 which was in A basically will now be copied to B. So A is going to B, and after moving from A to B, then what I will do, I have to divide by this remainder. So this 9 will be copied to A, then again it will go back here. Okay. So let me finish the rest of the part and show you the manual tracing. So on the right hand side block, bottom block, so initial is say A equals to 12 and B equals to 45. If it is, then if A equals to 12 and B equals to 45, okay, so this particular condition is false, so no exchange is required. Directly I will come here. Now B is 45, percent A is 12, and it not equals to 0 because the remainder is 9. So it is true, that means it will go inside this one. Then B percent A will be evaluated as 9, that will be stored in temp. After storing in temp, then A, the 12 will go to B, and then 9 will go to A, and after that it will go here, then it will be dividing that one. After the division, B percent A will get 3 here. Now when it will get 3 here, then this 9 will go from A to B, and A will get 3. Now 9% 9% 3, then it will be evaluated to 0 because it is a perfect division, and after this division it will come out. Now when it will come out, where is your GCD? Because 3 is dividing 9, and as a result of that you got the remainder 0, so 3 is your GCD. So 3, where is 3? 3 is here in A. That's why when I am outside the loop, then printf, the GCD is percent %d A. Okay. Now if I assume that B and A both are equal, then by this modulo operation I will get 0, and if it is 0, then it will come out. In that case A or B both are same, so that's fine. Okay. Now this is another example, double your money. Suppose your rupees 10,000 is earning interest at 1% per month. How many months until you double your money? In this case also you do not know at the beginning that how many times you have to iterate your loop, and actually that is the question. So in this case you know that your termination of the loop is when the 10,000 will reach at least to 20,000. Okay, that is the double of your money. So the entire program is like this here. So initially you are writing double my money equals to 10,000. So please note this, this double does not mean that you are doubling the money. So this double is the data type double. Okay, double my money equals to 10,000. Next int n equals to 0, that is going to be my loop counter. Okay, now while my money less than 20,000, or as long as my money is not doubling, then what I am doing, I am computing that after the interest, that what will be my principal and interest. Now principal and interest, 1% is my interest per month. So my money equals to my money multiplied with 1.01, and n will be incremented. That way I will keep on looping, and when my money will be at least 20,000 or double, so it didn't mention that exact double, but at least say 20,000, when it will be, I will come out of this loop, and then what I will do, I will printf my money is double in percent of d months. Please note that it is not year, it is per month. Okay, so it will print that in percent d months. Now if the question is little bit changed, like suppose your rupees 10,000 is earning interest at 1% per month, how many years until you double your money? If it is how many years, then after calculating the months here, then you have to convert this month to the year, and when you will convert, then either you can report this many years, this many months, or you can report a fraction number that this many years based upon the question, and then you can print that one. Okay. Now maximum of positive numbers. So here is an example. So let me show you the program first, then I will keep on explaining one after another line. So initially, so maximum of positive numbers, you please look at the problem definition. Maximum of positive numbers, that ensures that your number is not a negative and perhaps it is not also zero. So when I am interested to calculate the maximum of positive numbers, then what I will do, that I will initially assume that okay, my number is some negative number, or say my number is 0. My number means my maximum number or the result. So better I can say that okay, so when the problem is maximum of positive numbers, then better that you assume a number which is not positive number, or which is not obviously a maximum number for the given input. That's why I am assuming double max equals to 0, and next is another variable. Now printf, enter positive numbers end with 0 or a negative number. Okay, so 0 or negative number I am assuming that is not a valid number for this particular problem statement. So I am using that one for my sentinel character. Now scanf, %lf and ampersand next. So I am reading the next number, while next greater than 0, which means it is non-zero, non-negative number. Then if next greater than max, then max equals to next. And inside this loop, so here there is a scanf, again like the previous example of the reading the marks. Okay, I am reading the next number, and after reading the next number I am going back to this loop and I am testing with this one, and again I am checking that whether this is my new max number. If yes, then I am replacing the previous max number with this new max number, otherwise I am retaining that one. One important thing also to notice here is that you look at this, I am initializing max with 0. So there is no chance that I will get a positive number which is lower than this, since I am comparing with this greater than. Otherwise mistakenly I can have one output or one result which doesn't belong to any number. So one example I can give you. Okay, say for this particular input, if instead of max equals to 0, I assume that my number is say double max I am assuming is say 10. Okay, if 10 is my maximum number, then in this program, okay, if I supply or user supply 1 2 3 4 5 6 7 8 up to 9 numbers but not 10, then it will always show that your result or your maximum positive number is 10, because this condition, since it is reading from the input this ampersand x, and I am supplying 1 2 3 4 5 6 7 8 9, okay, then this particular condition, if next greater than max, will be always false, because I am assuming max equals to 10. So the suggestion is that when you are looking for maximum number, you try to have a very minimum number or very low number as an initial assumption with the maximum number, which will be just opposite for looking for minimum number. So if you are looking for minimum number, you assume very high large number as a minimum number, then in the first instance it will change, and when it will change, then it will have some value which is part of this list. Okay. Now the final example we will discuss now is find the sum of digits of a number. So when I say find the sum of digits of a number, then I can give you one example. If you note down the number, say 1, 2, 3, 4 or 1234. The sum of the digits of the number indicates when the input is 1234, then your output will be 1 plus 2 plus 3 plus 4, which is actually 1 plus 2 3, 3 plus 3 6, 6 plus 4 10. That will be your output. Similarly, if I give you a number like 12, then your output will be 3. If I give you an input 24, then your output will be 6. If I give you input 37, then your output will be 10. That way you have to output the sum of the digits of a number. In this case, I am interested to sum only the input number, but after getting the input number, after taking the sum of the digits of the input number, I am not adding the sum of the digits of that number. I will just output that one. Okay. Now how can I do that one? In order to do that one, you have to understand that how, say, one number, if I say 24, is being constructed. So how 24 is constructed? It is 2 multiplied with 10 plus 4. Okay. How, say, 123 is constructed? It is 1 multiplied with 100 plus 2 multiplied with 10 plus 3. Okay. That way, if I wish to know that what is my digit, then what I have to do, that I have to divide that one. So using division and using the remainder operation, I will calculate that one. How? Here is the program. So let me open the program first for you. Okay. So what I am doing, int n, so the input number whose digits will be added up is read and stored in n. Sum equals to 0, that is initialized with 0. The digits will be added in sum. After reading the number using scanf, what I am doing, while n not equals to 0, if n is not 0 definitely, then what I am doing, it is sum equals to sum plus n percent 10. So when I am doing n percent 10, then what I am doing, you see that when I am dividing a number by 10, then what will be the remainder? The the least significant digit will be my remainder. So if I divide 24 by 10, then my remainder is 4. If I divide 31 by 10, then 1 is my remainder. If I divide, say, 1234 by 10, then 4 is my remainder. So I got that 4 and I am adding that 4. After adding that 4, so 4 is gone from 1234. Next, what I have to get? I have to get 3. In order to get 3, what I will do? So after this n modular n percent 10, I got 4. Next, if I do n slash 10, since that is an integer division, so 1234, if I divide by 10 and if I store an integer, then it will not be stored as 123.4. Rather, it will take only the integral part, and that is 123. Because you look, n and sum, specifically n, sum is not required here, n is an integer variable. So if n equals to n divided by 10, then the division will be integer division. If it is integer division, then 1234 divided by 10 will evaluate to 123, not 123.4. If it is 123, now you see that in this line 1234 has converted to 4 because of this n percent 10. It has converted to 4, and that 4 is added here, and in the next line 1234 because of this division has converted to 123, and that 123 is now reassigned to n. Okay, then from here it will jump here. 123 is not equals to 0, so it will come here. Again I will do this modulo this percent operation, and this using this percent operation, basically 123 will get the remainder 3, and that particular 3 will be added to sum, and after that addition here is another division, 123 divided by 10, so I will get 12, and this 12 will be assigned to n. It will go here, then from here I will get 2, then 2 will be added, then after this division I will get 1, because 12 divided by 10, so integer division I will get 1, then 1 not equals to 0, it will come here, then remainder is 1, so 1 will be added. Now 1 divided by 10, integer division is 0, it will go here, it is 0, and because of this 0, then basically you will get a false statement here, and the loop will break, it will come out, and the sum will be printed here. Okay, so that's it for now. Okay, so what we studied, that the motivation for the iteration and the loop, we see some examples of having the advantage of say iteration and loop statements here, and we discussed in detail the while loop. In the next lectures or slides, in the video lecture specifically, we will discuss other loop constructs like for or do while. Okay, so thank you for today. So if you have any questions or queries, you do not forget to post that one in the query form. Okay, nevertheless we will have other doubts also, irrespective of which is posted in the query form during your class session. Thank you.